So again, today's date is 20th September 2021, and we are actually going to best first search algorithm. Okay. So this best first search actually try to choose the path with a minimum cost in a given graph. Okay. Best first search try to choose the path with minimum cost in a given graph, but this minimum cost is only regarding the adjacent node. So it not consider the entire graph when it comes to choosing that particular say graph node. Basically is basically uh, greedy search algorithm which try to choose minimal cost path from what you can say source, called as a source to destination. Okay. So when we say destination, usually in adjacent nodes. So now if we consider this, okay, if we let me change the color of the screen. If we want to go from this S to G, what this will do, it will select first, because it will compare this best first search BFS will compare 2, 3 and 4 and will select 2 because 2 is having minimal cost. Okay, then it will select check 6 and 5 and it will select this 5 because 5 is having the minimal cost, and now it will go through this 8 because there is no other path if you consider, but that not happen. Okay, that not happen because for this E the minimal cost path is 3, not 8. Okay, so it will select the minimal cost. You are getting? And for this node, this is the only explorer thing, so it will go and select this path. You got what is the disadvantage of greedy algorithm? Hello, this is simple greedy algorithm. This is simple greedy algorithm without any artificial intelligence added to it. It simply select the minimum cost path. So what will happen when it reach to E, instead of going to G, it will go to minimal cost path, that is 3, and it will go back to S once again. Okay, so the path cost will be very high. So greedy algorithm, when you choose, many times won't give you the proper output, won't give you the proper output, or the output will be very costly. For example, let's say suppose if you are having a graph like this, okay, this first, second, okay, third, fourth, and you say this is fifth, and this graph is having connectivity like this, suppose that is this is connected to all these three. Okay, and then this is connected to this is connected to this, like this, but the path cost is like 1, 2 and 3, and if this is your start node, this is your start node. Okay, and no matter which of these three is your goal node, if you apply the greedy algorithm, it will always choose the minimal cost path, and it will reach to this node first. Okay, it will not choose this 2 or 3 because 2 and 3 is having more cost than this one, more cost than this one. You are getting this? Hello? कंसिडर ये हाँ, ये पुणे सिटी है, ये नगर है, ये नासिक है, सॉरी ये लोनावाड़ा है, ये नासिक है, ये मुंबई है, एंड दिस इज कोल्हापुर. Okay, this is say suppose कोल्हापुर. Now you want to go to मुंबई. और कोल्हापुर से मुंबई तक कोई रास्ता नहीं है. बट पुणे टू कोल्हापुर 100 किलोमीटर है, पुणे टू लोनावाड़ा कंसिडर 200 किलोमीटर है, पुणे टू नासिक कंसिडर 300 किलोमीटर है. तो योर बेस्ट फर्स्ट सर्च using greedy approach without any artificial intelligence will always choose the path which is having minimal cost in the adjacent node. अब ये start को adjacent node कौन से this A, B and C, but the distance 1 is minimum than these 2 and 3, so it will choose this, and here you are having no path, so you will get stuck. Greedy algorithm many times not actually offer you the best solution. It many times simply give you the wrong solution. So in this case you need to backtrack. When you backtrack, what happens? जाने का 1 किलोमीटर हो गया, आने का 1 किलोमीटर हो गया. So 2 किलोमीटर is added here, 2 किलोमीटर इज एडेड हियर. अब हम क्या करेंगे, ये दोनों में से जो मिनिमल कॉस्ट है उसको चूज करेंगे. सो लेट्स हियर 2 इज द मिनिमल कॉस्ट. सो नाउ वी आर एक्चुअली हैविंग 4 एज अ कॉस्ट. ओके, और यहाँ पर भी मिनिमल कॉस्ट किसकी है, समझो इसकी कॉस्ट मिनिमल है. लेट्स कंसिडर दिस एज अ 2, okay, and this as a 3. Then your greedy algorithm will not choose this, instead it will go to choose these 2, and if this is 4, okay, this will go in this direction. So obviously it will always give you the worst kind of what you can say situation, क्योंकि वो मिनिमल कॉस्ट पाथ जो है वो चूज करता है. व्हाट इज चूजिंग? minimal cost path. So the heuristic value is added here. Heuristic value is added in this functionality. I'm just making control Z to disappear all these functions. Best first search. When added with heuristic function, generally shown as a small h of n, okay, always guarantee you the what we can say solution. I'm not saying the optimal solution, but it always guarantees the solution. And this is what we can say best first search. This is called as heuristic search. Heuristic best first search. Now it is not greedy. It uses the greedy approach, but it is not greedy because you are having some h of n here. And to explain this, let me erase first this graph and then we'll see. So here we are having what? Now I'm once again drawing the same similar type of graph. Here you are having your start node. Let's make it as a source node. Consider this here or your starting position, and here you are having this node A, okay, node B or city B, this is city C, then you are having here city E. Now here you are having city F, and here you are having your city goal. Let's consider that G. Here you are having some random cities in a graph. Okay, you can name them whatever you want. Okay, and they all have the connectivity. So let's say that this is connected like this, and to goal state. This connected like this, and here this may be connecting like this. So what happens in the this simple what you can say base first search when it's added with a heuristic value. So let me change the color of line. So here you are having the start line. Yeah, this is your start, and this is your goal line. This is your goal line. So if you draw a graph here like this, just consider this as a y x and y axis. You are having the graph. Okay. So how this h of n is calculated? Okay. So this here, if you consider this as a origin, then you are having this one, you are having this two, here you are having here three, here you are having this as a four, here you are having five, six, seven, okay, eight, and 9. Okay, so from 0 to 9. So what we consider from S to G, what from this S to G, the straight line distance is 9. What we consider that S to G is a straight line distance which is 9. Okay, so let's try to type this distance and say S to G equals to 9. This is our straight line distance. So here what from S to G is 9. Now you are in this A. From A to G, what will be the distance? 9 minus 2, that is 7. So from A to G, what is your distance? It is 7. Okay, from A to G, we are considering this. A to G, what is your distance? Hello?
7.
7. For B, it is once again 7. Yes. B to G, it is also 7. Because they are on a same level. Okay. For C, for C, this distance or heuristic function shows that a straight line distance from C to G, is again equals to 7. Okay. Now it comes to this E and F. When it comes to E and F, so what we are having 1, 2, 3, and 4. So E to F, okay, E to F distance is equals to, you are having if you 1, 2, 3, 4, that means 5 you will get. Okay, and now this is A, B, C, and this is D, and sorry, E to G, D to G, and D to say D to G is 5. Here you are having the distance E to G, E to G as equals to 5. Now this is E to G is 5. Then you are having this is D, E. The having is F. Okay. Now what is the straight line distance from F to G?
2.
It's not 2, it is 3 because you get 6 here. 1, 2, 3, 4, 5, 6 is something here. So from this E to what you can say F to G, F to G is equals to uh, 3 actually, because you are negating that distance from this thing. So F to G is 3. Now here let's call this as I and this as H. So for I and H it is 2. For I to G, for I to G it is 2, and for this H, what we could say, okay, from H to G it is again 2. These are the distance calculated, and G to G you get 0. So that is your goal node. So G to G is 0. That is your distance. So if say suppose the costs are given like this, here you are having the 10 as a cost, here you are having the 11 as a cost, and here you are having some XYZ as a cost. Okay, the heuristic algorithm of best first search won't consider these cost of the path to travel from source node to destination node. Source node to destination node. Instead, it uses the distance of goal node from that particular destination node. So from S, the distance is highest, that is 9. So it must have to reduce this distance, means you have to go to the nearer to the goal system. So here you are having all three options, we are having there 7. Okay, so it may choose any option this because it is the base first and it is a priority. It is a base first and it is generally uses the priority queue because you have to go with the greedy types things. So it chooses 1 because all are 7, it chooses any one out of it. So let's consider that it first choose the A. It first choose the A. So and it register this yes and A. Now you are in a node A. In open base you are having all these nodes. Now you are at a place A. From A to G, from A to G, what is the distance that you are calculating? Okay, the distance is choose. Now here from this A you are having only this A, B, C, only D is there. So from A you have to go to the D. Obviously because you are only having that connected. So from S to A you go to the D. From S to A you go to the D using this heuristic distance formula. Now this D is connected, okay, this D is connected to I and what you can say I and this what we call as
H.
E. Okay, because this is our D, E, and we said H. Okay, so D, E, F actually. So we are having this F here and H here. So we will select based on the heuristic distance. So if F is 3 and I is 2. So instead of going to this, we'll go to this. Okay, we will go to this. When we select this, what happen? We will try to find out the distance from this to goal. So obviously from I to goal is 2, so we come to the goal node. We come to the goal node. So in best first search, when we are using the heuristic based first search, which is used in artificial intelligence and not the plain greedy based first search algorithm. Okay, because plain greedy based first search algorithm considers the cost of path, while the heuristic based first search or artificial intelligence based first search or simply BFS, if you want to add, it consider not only the path cost, okay, it just consider the instead of considering the path cost, consider the distance of goal node from the source node. Okay, so from every node it calculates this distance. Now we are using very what you can say primitive way of calculating these distances from that particular node to goal node. You are getting this, everybody?
Yes, sir.
Yeah, because if you don't get this thing, it is quite difficult to understand the base for such working. Okay, now let's see what type of HN are used. Now you know that we are having this as a y-axis. Okay, this as a y-axis and this as your x-axis. As you know, if you consider this as a 0 comma 0, that is the origin of your graph, you know that for every point you are actually trying to find out distance from this to your goal node. Distance from this to your goal node. There are two methods of calculating these distances. First is the Euclidean function. Okay, Euclidean function or distance, what we call as this, sometimes also called as a straight line distance. Euclidean distance is sometimes also called as what you can say straight line distance. Euclidean distance is also called as sometimes straight line distance. And this straight line distance is generally given with, I'm saying that SQRT, that is square root of, okay, so instead of writing, I have to draw this function. Writing will not justify it. So Euclidean distance is given with this simple function. Uh, Change the color. So Euclidean distance h of n can be considered as a square root of what we call as a point goal xg minus what we call as a xs, that is a source, okay, square. Yesterday we have seen this, plus you are having y2 or yg minus what we call as a ys square. So this formula is generally used to calculate the distance from the starting point to goal point. So this xg is constant here, yg is constant, that is the parameters of your goal point. Here you are having xg, okay, this because you are having this goal, your goal is set here. So you are having xg, in comma, you have yg here, yg here in a given graph, and then for you are taking per se a difference, and here you are in this xs. Okay, next time when this xs say, that is this how the minimum distance, okay, xs value changes continuously and you calculate all the distances. Just right, we calculated only linear distance, straight line. Okay, we consider only 1 2 3 4 5 like this, but these distances are calculated like this. This is called as a Euclidean distance. What this called as? Hello, anyone of you? This is
Euclidean.
Euclidean distance. Play. Euclidean distance. UCL.
The screen is not visible.
Now it's visible. Okay, so this is a Euclidean distance. This is the one way of calculating, which is shown using this function here, what we call as the h of n. So here in your thing, this function is given with a h of n. So you are actually calculating the value Euclidean distance, and you are not considering the cost of that road. Not considering the cost of that road. For example, let's say suppose if you are in a city here, Pune city is here, and another is the some XY city, and just consider from Pune to this city you are having a path like this. Okay, so the straight distance from Pune to this city, straight distance from Pune to this city, or straight line distance may be some say X kilometer, and the actual cost may be some X plus K, X plus K. Now what is the cost of traveling a path? समझो आपका 1 किलोमीटर का रास्ता है, that is your straight distance of 1 kilometer. Okay, and if you go what you can say on bicycle, the time required to travel will be to say 2 hours. If you go on motorcycle, maybe 1 hour. If you go in a say four-wheeler, it may be in half hour, like that. So the cost reduces with the other things, but straight line distance remains constant, and so this heuristic function chooses this straight line distance. But these heuristic functions which calculate the straight line distance need to be simplistic enough. Otherwise, what will happen? The computation will mug up everything here itself in calculation of h of n, and the algorithm will become more complex than easier. So the basic greedy algorithm, greedy search algorithm, is actually converted into an AI algorithm just by adding a simple function into it, that is called as a heuristic function h of n, and this is called as thing. There is another way of calculating. This is the Euclidean distance which is calculated like this, and another distance which is calculated is called as a Manhattan distance. Okay, so Manhattan distance, these are the two functions to calculate these straight line distances. Okay, the Manhattan distance can be calculated as mod of what we call as a I'm saying xg, okay, minus this xs, that is a starting or source state modular, minus you are having mod of this or this yg minus you are seeing ys starting. So here you are not taking any square or anything. Instead, what you are doing, let me use the eraser so that you can see it clearly. Okay, so this is the Manhattan distance, which is huge. So here what we are taking, the absolute thing means if xs is more and this yg, say the distance is calculated, and xg minus xg, when this xs become equal to xg, it will become what is g to g is zero distance, and that is how this best first search things work. Now what will be the algorithm for this BFS? So let's try to write down the algorithm for this. So what it says, BFS algorithm, or we can say heuristic algorithm actually. So when say best first search algorithm, okay, algorithm with heuristic value h of n. This h of n may be the Euclidean distance, or this h of n may be Manhattan distance. Okay, let's say that is maintain priority queue, priority queue, q e u e q. Okay, let's call this priority queue as so it's given me the small q, and then you have to use some loop condition. It may be the while loop or something. Okay, or repeat what you can say, and you are saying that is if your queue, okay, is empty, queue is empty, obviously queue is empty, what will return? Return the failure, that is there is no possibility of what you can say uh, having any path because queue, the main priority queue is empty. अगर ऐसा नहीं है तो आपको क्या करना है, you have to go else you have to have say node, and you can say this node tends to what you can say you are remove, okay, you are remove first from the queue, that is whatever the node is there in the queue that you have to remove, because start node you have to update continuously, and then you have to check if this removed node, okay, is equals to goal. If removed node is equal to goal, okay, what we are saying, you have to say return path, you have to say return path. Otherwise, okay, when you say return path, we are actually returning path from what we say, return from S to G, that is from your actual source node to goal node, not the intermediate source node. Return path S to G, okay, or in, or if it is not equal to G, goal, then if node is not equal to goal, then else what to say, let me make this uh, so you will come to know else. Else what, you are remove this, else what you generate all successor node. Else you have to what can you say, gen all successor node. Okay, this will end this if statement. This will, for this if you will get end if. Okay, it is in a loop, and if k is empty, then and for this if you will get here end if. Okay, and then here what you get end loop, what you are actually returning this entire path. So this is the brief what you can say slow algorithm for your best first search. If you have any queries, questions, any problem, I can say problem, if you are not understood anything, you are free to ask. So what we are having here, a given graph, we are considering here as a, now I am just adding 4 cities here, only 4 elements. Okay, here you are having a what say some bended road, here you are having some straight road, here you are having some straight road, okay, and what, say suppose this bended road cost is 3, एक घाट आहे त्या घाटाचा this is 4 and this is 7, this is 7. Here you are having your source, here you are having your goal. Okay, this is your A node, this is your B node. Yes, now just apply simple greedy algorithm of best first search. What will happen? Simple greedy algorithm will compare the cost of these two paths from the source to adjacent node, and what will be the cost? 3 is the minimal cost, so it will choose these 3 and will get stuck here and will never reach to the goal state, will never reach to the goal state. But if you add, but now if you add what say our heuristic values here. Heuristic values here. Okay. So what you get here, x and y. Okay. Now consider this x and y. We are having distance like say this is as a 1, this as a 2. Okay, and this is 0. To form S to G, your distance is, what is say, from S to G, distance equals to 2. Yeah, from A to G, from A to G, what is the distance? From A to G, any one of you? Hello? Hello students, your reply. Hello?
Sir, repeat the question.
What is the distance from A to G? A to G? Because there is no connectivity actually, it is infinity. You can never reach from A to G because there is no connectivity. This straight line distance is calculated in that way only. Okay, and here you are having this from B to G. What will be the distance? B to G, your distance is actually 1. Okay, and from G to G, your distance is equals to 0. So now if you use the same best first algorithm using heuristic knowledge, best first algorithm, greedy algorithm using heuristic knowledge, that is you converted into artificial intelligence thing, what will happen? I'm just changing the color here. It will check the heuristic value from S to B and S to A, and it says that from S to G. So heuristic value for A to A to G and B to G. A to G is infinity, so it will not choose even the cost of this path is lesser. This path instead it will go from S to B and from B to G. So what you get, the what you can say, a solution. This solution may be good. This solution may not be good, but you will still get some solution due to this heuristic nature. Due to this heuristic nature. Due to this heuristic nature. And even if you go with the say our simple thing, this is what we say, we come up with our analogy here. Now instead of that, if you choose this something what we call as or Manhattan distance, or if you consider Euclidean distance, then also you will find the distance from A to G is quite big, more than distance from this B to G. You can calculate it on, you can on graph, you can draw this and you can calculate that. And in that case also, instead of choosing this path, this heuristic based first search will always select the what you can say, the path which will guarantee you the goal state. So this is the thing of the best first search. It is very efficient if you are having a very small number of nodes in a graph or a tree, but it may not be that efficient if you are having the infinite or sufficiently large numbers of nodes in the graph, because calculation of h of n, that's a heuristic function, is the one thing. So when we say this BFS algorithm with h of n, we actually already calculated this h of n, okay, from the source to destination. So if you are having, say suppose this is the entire universe here, and in this universe here your point is there, your destination point is there, then this h of n generally calculated for using some distances, and instead of going randomly in any direction using the uninformed search of BFS and the breadth first search and depth first search, we choose the informed search. Okay, informed means you are in have the knowledge of heuristic distance or heuristic knowledge, or that what you call Euclidean or Manhattan distance, and then you calculate those distances, and irrespective of the cost of path, you chooses the node which is having less distance from the goal node as your next thing, and you return the path. You got this? Okay, so with this,
Yes, sir.
breadth first search is completed. Sorry, best first search is completed. It is an informed search. It is modified greedy algorithm with a heuristic value, and it is used in artificial intelligence uh, many times when it's to show you the different distances and likewise. I'm really thankful to all of you for attending this lecture, and ending the session now. Good day.